Morning.
Sir,
Well,
Assalamu alaikum.
Walaikum
Good
salam.
evening, sir.
Morning. We'll be waiting for other student to join. Then we'll start. Maybe we'll wait for a few minutes.
Yes, sir.
Yeah, thank you.
Sir, what are we going to study today? Actually, I missed the previous class.
You missed the previous class, right? So today we'll be studying about some like behavior of actual capacitor, inductor, or RLC circuit in a sinusoidal source or AC circuit. As well as probably, if I get time, probably we'll talk about instantaneous power of average energy, something like this. Yeah, depending on how much time can I manage.
Okay, sir.
স্যার কালকে ল্যাব ক্লাস থেকে আপনি নেবেন?
Tomorrow's lab class.
হ্যাঁ
Actually,
হ্যাঁ হ্যাঁ
yeah, I'm
জি
supposed to
স্যার।
actually take the class, but I'm having some family occasions to attend, so I will skip tomorrow's class. So Saba madam will be taking the class, but from the next week onward, I'll be taking the lab class, if I'm not wrong. Yeah.
স্যার দ্যাট মিন দ্য অফলাইন ক্লাসেস।
No, I will be only taking online classes. So
স্যার বাট
yeah.
আই ডোন্ট স্যার যেভাবে কথা শুনতেছি মনে হচ্ছে যে অফলাইনে ল্যাব ক্লাস হতে পারে তাই।
Actually, we had a meeting with departmental head as well as other faculty members, and they have instructed like from November 6th, we'll be having both offline and online classes, especially for labs. So you people have like completed a survey, right? In the Google Classroom, like whoever have actually opted for offline classes, they will be joining for offline actually lab classes, while whoever is preferring for the online actually lab classes or the classes, they will be actually allowed to have online classes as well. So uh, it's like the same actually class, but divided into offline as well as in online. Means at the same time, one group will go for offline, and another group will be going for online classes. This is what I was instructed to do. All the faculty members are instructed to do. But probably very soon, you all will get official actually email from the registrar office or as well as our department. I am not sure, and whoever have actually applied for accommodation, university will actually arrange the accommodation for them also, as well. Yeah, this is the update I know. I didn't check my email or anything for the last 2 days, so I'm not aware of this. We'll wait for another 2 minutes, then we'll start actually. Why students actually don't join in time? Is it because I don't take attendance? Uh, or I'm really flexible? What is the reason? I'm not sure. But maybe I can start because I'm recording the lecture. So whoever is missing the starting of the class, they can actually check the record recording. Maybe I can actually share my screen here. Am I audible? Means can you hear
Yes,
me?
sir.
Yes,
Yes,
sir.
sir.
Yes, sir.
Thank you so much. So if I remember correctly, the last week I had been discussing about like the resistive behavior and inductive behavior in a pure AC actually source, right? So if I remember correctly, we had covered this. So for the resistive actually behavior and the inductive behavior, do you have any actually question? Because I have uploaded the slides as well as the annotated lecture on Google Classroom if I'm not wrong. So do you have any problem till here? Like we can calculate the reactance, like frequency dependent induct, like just like in the resistance. This is the term we say in the Excel. Sometimes we call it actually reactance. Maybe I can write down a bit. This is called the reactance. Reactance. And we must actually remember the formula for reactance of inductor, because XL equal to omega times L. So omega is the angular frequency as well as actually inductor. So because you see all this actually calculation involves like uh, some sine wave or the cosine wave, and these are not so easy to actually like calculate all the time. So maybe after 2 or 3 more classes, and we'll see the AC circuit also can be actually solved easily using this relation. Like we can consider a inductor as a resistor, means that just like resistor in DC circuit you have used, and we'll actually also get some expression for actually capacitor. That capacitor we will get some expression which can be equivalent to the resistive term, means in that case we can actually modify everything very easily. So the last week we have found the expression for current in an purely inductive circuit, means the circuit is like this. So I have an inductor and it's actually powered by a AC or sinusoidal actually voltage source, and for that case we have got the same expression of current. The only thing is current lags actually the voltage by negative, sorry, 90 degree. So and the the maximum actually the maximum voltage value and the maximum current, the ratio between the maximum voltage and the maximum current would be given by omega L. Since we know from the resistance actually point of view, the voltage by current, that will give you the something called resistance or resistance like things, something equivalent to resistance. For our AC circuit we called it actually reactance because it has a frequency dependent part. We know omega equal to 2 pi f, right? 2 pi f. So anything equivalent to resistance but it has a frequency dependent part, that thing we call it as reactance. So reactance of the inductive circuit or inductor is given by omega times L. L is nothing but the value of actually the inductor. Am I clear? This far means it's not that difficult. So for a inductive circuit, if I have a like voltage source and connected with an inductor, then the response would be the voltage current response would be the voltage current response would be like this. So if the voltage is something like this, Vm sine omega t, then the current expression would be same, like only the thing is it will lag by 90 degrees. So it will lag by 90 degrees. And the second thing, since this is voltage and this is the expression for current, the maximum current should be What is the formula for current? Current means voltage divided by reactance. Generally, in DC circuit, we say the current is voltage divided by resistance because it doesn't have any actually frequency dependent term. But in the AC circuit, if you have inductor or capacitor, it will contain a frequency dependent part, and that's why we call it actually reactance. So what was the reactance for inductive circuit is omega L. So the current expression would be the maximum voltage divided by reactance. So for our case, this reactance is omega L. So we just write it down. So basically, this is nothing. This is like Vm divided by XL. Am I clear here? So now the question is, if I want to draw, the waveform for, the voltage and current, the voltage is, since it has no actual phase difference, means omega t only, then I will only draw. And the second thing is, the current will actually lag, the voltage by 90 degree. What does it mean? It will start from the front. So we know this point is 90 degree, right? Because this is 0, this is 0 degree, this is 0 degree, this is 180 degree. So the middle point should be 90 degree, and it will start from here. Now, what would be the maximum value depending on omega and L? If omega L is greater than 1, then the maximum value would be less than Vm, because Vm divided by greater than 1. Let's say omega L equal to 2. That means this value would be Vm divided by 2, this value. And if omega L, omega times L, is less than 1, that means this one would be greater than what is it called? Greater than actually the source actually voltage. Because if omega L less than 1, let's say I consider omega L equal to 0.5. If this is the case, so Vm divided by 0.5, it means 2 times Vm. So it will be just double. Am I clear? Is there any confusion so far? There's a pretty straightforward.
No, sir.
Okay, I have again a question for you all. Now, I said a very simple actually circuit. This is the voltage source, and again it's connected to an inductor. So right now I have an expression of Vs equal to, let's say, 10 sine omega t plus 40 degree. Can you tell me what would be the, can you tell me what would be the expression for, current here? Can you hear me? Or I'm actually talking
Yes, sir.
too slow?
It's audible.
Thank you. So if, this circuit is actually energized by a voltage source, and the voltage source look like this, then what would be the expression for current? Any idea? Can anybody answer?
So Vm by omega L.
Minus 90.
Okay, I said, the value of, let's say, omega L equal to 5. So what would be the expression?
Vm by 5, sir.
Perfect. Then only Vm by 5? This is
Vm
the
by
maximum one.
Vm by 5 sine omega t minus.
Minus? Yeah, that
Minus
is the
90
thing.
degree.
9,
Minus 90 degree.
not only
minus
90.
Not only 90. Yeah. Then what would be the expression? I wanted to hear this one. Try. If you make mistake, it's fine.
Minus 90 minus 40.
Minus 90 minus 40. Why minus 90 minus 40? Look, the thing is, the current expression is Vm divided by XL. Then we'll write down sine. Whatever I had for actually voltage, that will be actually lagged by minus 90 degrees. So I already have omega t plus 40 degrees. So I will just write omega t plus 40 degrees because it was already there, and then it will lag by 90 degree. So for my case, Vm equal to 10. This is 10 divided by XL value is 5. Then I'll write down sine omega t minus how much? Minus 50 degree. Okay. So if I want to draw, can we draw? Yeah, it's a like task, home task. It will not be graded, but you can practice like how would actually that web form actually web shape actually look like. Let me actually save it. Annotated one. All right. Oh, okay. I need to start from the beginning. So now, if we know the behavior of actually inductor in a AC circuit, we can also actually explore another basic element in AC circuit is called capacitor. So for simplicity, right now for simplicity. So basically, before actually I go for the capacitor, we all know this, right? The current we just have seen that current will lag actually voltage by 90 degree. Means in inductive circuit, in an purely inductive circuit, the current always lags, and that lags by actually 90 degree. Okay, so this is one of the thing. Now just think about a capacitor. So if I have a capacitor, let's say, and it is energized or connected to a voltage source, and this is a pure actually sinusoidal or AC the voltage source. So generally we consider some expression like this. But in exam, this expression might be different. I can actually give other example, like I can put in the cosine here, I can put cosine here, or instead of omega t, I can put in a omega t plus theta. So this is nothing but when you will actually plot the waveform, for the waveform it will, depending on the plus or minus, it will be lagging or leading with respect to actually the original 0 point. So other than that, there will be no differences. And how do you actually get the current? So, since the voltage is given, so if you remember correctly, for the actually inductor, we can calculate the voltage, right? For inductor, what was the formula? VL equal to L di by dt, right? So that was the relation. So for inductor, we can calculate actually voltage because the current passing through the inductor, means the coil, that is changing with respect to time. But for the capacitor, the things is completely different because capacitor is parallel plate capacitor is like this. So this is plus, minus, or something like this. So for parallel plate in the capacitor, we have positive charge here and negative charge, something like this, and this is the something like this. So for the parallel plate in a capacitor, or generally in a capacitor, the thing changes is voltage. So whatever the voltage actually we got actually across the real capacitor, means the material, that changes with time. And what is the current actually passing through the capacitor is given by that relation. Probably we all know this relation, like current I equal to C dV by dt. Now what does it mean? That this current means the current passing through the capacitor,
Change
and
in
this
voltage.
voltage, change in voltage, exactly that wanted to say, the change in voltage with respect to time times the capacitor. So right now, if we know the relation, then the rest are so easy, like normally differentiation. But for this case, for this case, if I want to calculate current, I had to do integration. So since integration and differentiation are just opposite in terms of actually multiplicative factor, then we'll get actually different relation for capacitor. Let's check it out. So what I have done, I have just substituted actually the value of actually capacitor voltage here. So this is Vm times sine omega t. Since Vm is a constant, so I can take it out. So Vm times like C, and d by dt times sine omega t. What is actually differentiation of sine, right? Cosine omega t. But since it's a differentiation with respect to time only, the constant term omega, that will come out, and it would be a multiplicative factor here. But the main expression for the voltage source was sine, the sine omega t. Since the first the main source is actually sine, I need to convert that cosine, and we all know the formula for changing, right? So I'm not writing it again. So finally what we'll get the sine expression and everything. So, but there is actually a term called plus 90 degrees. So if this is plus 90 degree, what does it mean? Like current is leading or lagging?
It is leading.
Yes, perfect. So this is a leading current. So the opposite thing we are learning means in inductor current lags, but in capacitor, current actually leads. Now check out the maximum value of the current. So what is the maximum value of the current? The whole thing, right? But I know the maximum value of the current is nothing but the ratio of the maximum voltage divided by, sorry, no, I'm wrong. So mm, XC. Yeah, this is I'm right now. We know the resistance like things that we call it actually reactance is nothing but the Vm by Im, right? The maximum voltage divided by maximum current, that we call actually reactance. So this is reactance. If this is reactance for capacitor value, the reactance is like how can we check? From that relation, we can also write Vm divided by Xc, means I take this one here, this one here. So Vm by Xc equal to Im. So I know this value is nothing but the maximum current. So if this is Im, let's say I write down Im equal to C times Vm. So what is the Xc value? Xc means Vm divided by Im equal to 1 upon Xc. Sorry, 1 upon omega c. Do you understand? So for
Yes.
yeah, so if this is the case, so what I wanted to say is um, for a capacitor value, two things happens. The current actually leads by 90 degree, and what is it called, like frequency dependent resistance. We don't call it resistance because it's a reactance thing. So the reactance for actually a capacitor value is nothing but the 1 upon omega c. What does it mean? Let's recall again. For inductor we got omega times L. For capacitor we got 1 upon omega times c. So some people say 2 pi fl because omega equal to 2 pi f. Some people write down like this, 2 pi fc. So we can see actually two completely different behavior for a inductive circuit as well as actually capacitive circuit. So if you think closely, if I increase actually frequency here, then the reactance of inductor will increase, but the reactance of capacitor will decrease, right? If frequency I increase in the frequency, then XL will actually increase, but XC will decrease, or vice versa. If I actually decrease the frequency, then XL value will decrease, whereas actually the XC value will increase. And this is so easy things, right? Now, in terms of actually current behavior means leading or lagging, that is also changing. Like for uh, inductive actually circuit, current actually lags by 90 degree, but for a capacitive circuit, current actually leads by 90 degree. So we know the expression. If this is the expression, can we draw the waveform? That is so easy. So this is the Vm sine omega t. Now we'll draw the second thing, the current means the Vm divided by Xc. So Xc value is 1 upon omega c. Just I have substituted actually that value, and it will actually lead by actually 90 degrees. So lead by 90 degree means it will start 90 degree from the behind, something like this. So do you have any question for this, because these are quite easy? Any question?
No,
Yeah.
sir.
Thank you so much.
No,
If you don't have question, um, let's say you have a okay, Vs equal to 5 cosine omega t plus 10 degree. Can you tell me what would be the expression for current here? Yeah, I can actually give you the value xc equal to 1 upon omega c equal to, let's say, 2. Can anybody try?
10 cos omega t plus uh,
10 cos omega t plus
omega t plus 10 plus 90 degree.
Thank you so much. And the answer is correct because we know the formula is Vm divided by Xc. This is the formula, right? So not 10, that should be 2.5 cosine. Whatever is here, I will just write it down. Omega t plus 10 degree. Since the current actually capacitive branch leads by actually 90 degree the voltage, so I will write down plus 90 degree. So what I will get is 5 divided by 2, then cosine omega t plus 100 degree. Am I clear? Hello?
Yes, sir.
Sure.
Now I will actually ask another question. It's just a basic question. If you look closely, for this actually circuit, I have replaced sine by cosine, but still I have written the same things. Am I wrong, or I have to actually convert it to sine first?
Sir, convert it to
No,
sine first.
no,
Okay.
sir. It's all
Sir,
right.
Okay,
Because the
the both
with
answers are correct. Okay, both answers are correct. So since I didn't mention like express everything in terms of actually cosine, now my reference voltage is cosine. So make sure whenever you got the current, it has to be written in cosine also. But if somebody thinks, oh, I have learned everything about sine, I have no issue, convert this one to sine. But if you convert this one to sine, you'll write the expression for sine. Otherwise it will not work because these two are completely different things. So this is the case. Any questions so far? Then if there is no question, we'll actually practice some problem that it will actually clear all the like confusions and everything. So if there is no question, let's actually get back to a practice problem. So as I said, there is actually the question says the voltage across a resistor is given by equation, certain equation. Find the sinusoidal expression for current if the resistor value is this. Now, can you tell me what does this sinusoidal means? Does sinusoidal means only sine or
no, sir,
cosine as
cosine,
well?
cosine also.
cosine also.
Both
Cosine,
sine and cosine.
cosine also, right? As I said, just a few minutes back, like since this is given in terms of sine, you don't need to change anything. Just keep it sine. But if you convert it to cosine, I have no problem. But the final expression has to be actually like given in terms of actually cosine as well. Means the mother actually expression or trigonometric expression and the final expression should have the same baseline. Means either both will be the cosine or the sine or something like this. So if this is the case, basically we have been talking about a circuit, and this is like V of t, and this is connected to a resistor. So if you actually remember closely from the last week, we have been reading for the resistive circuit, current doesn't lag or current doesn't actually lead, means they will be in phase, means the phase doesn't change. Right now the initial phase is, this is omega value, omega is 377, t plus 60 degrees. So this is the phase. So current will be having the same phase. Then what does change? The only thing changes is the magnitude. So what is the formula for magnitude? We know the magnitude value, right? Vm by Im, this is the magnitude, but resistance is not a frequency dependent term. So that's why this is called resistance. But for the AC circuit, anything actually depends on frequency. We'll be calling it as actually the reactance, like as just have seen the reactance per capacitor, or reactance per inductor or something. So since the formula is like this, so current is nothing, so V of t divided by R. So R is a constant value, right? Constant is here, R is 10. So I will just write down I equal to 25 sine omega t. Omega means 377, you'll be writing plus 60 degree divided by 10. So this is all we'll get. So what is the maximum peak value? 25 divided by 10 means 2.5. And we all know since resistance doesn't have any phase here, so the phase should be in the same, like omega t plus 60 degree. Is there any confusion? Because this is the simplest thing you can do.
No, sir.
No? Okay. If there is no okay, there is a disclaimer, like we don't have actually electricity in our area for the whole day. So I'm using actually my laptop. I don't know how long will it actually back up. In case it's not working, means the laptop is shutting down, then realize there is no actually like power left. But hopefully I can finish the class. This one is the case, and the second case was the even the simpler one. So similar things, the current passing through a coil. So if you check that unit, so this is nothing a inductor. So circuit is like
স্যার
this. Tell me.
স্যার লাস্ট প্রবলেমে যদি ইম্পিডেন্স বের করতে বলতো তাহলে কি করা যেত?
Yes, thank you. It's a good question. So, as I said, the resistance doesn't have any actually frequency dependent term because it doesn't actually depend on frequency. So, whatever resistance you will get for the resistive circuit is called the same thing called impedance. Impedance is a bigger
Sir.
branch.
Yes, sir. Sir, in my case, can you just clear this for me? That is impedance is just kind of a resistance for
Yes.
everything that we are using, like capacitors, also inductors, and in this case also resistance as well, right, sir?
Thanks for actually raising the concern. Sometimes we get actually confused, like sometimes we are saying resistance, we do know what is it called resistance, but when we say actually impedance, what does it mean? So resistance means the ability to stop something or prevent something in DC circuit, because in DC circuit there is no frequency, but in frequency dependent actually circuit, in frequency dependent circuits such as like the capacitor or inductor, or even in frequency dependent circuit if you use actually the resistor, we call in general everything that ability to stop current or anything is called impedance. So impedance is equivalent to resistance, but resistance is less general term just for DC circuit. But when we actually deal with actually AC circuit, that we call it impedance. The only difference is impedance can be complex number, means it should have a
vector
magnitude
term.
magnitude as well as the angle. Means for the resistive term, the expression is like this. Look, this R is resistance, this R is nothing but the resistance because it's a real number. Am I clear? Because it doesn't have any actually angle. But some people say, oh, I can express any number into complex number. We can write down, right? Because can I write down like this? It's a complex number, right? Or
Yes,
then
sir.
angle in a 0 degree. I mean, in complex form, it's not a complex number, it's a complex form. So this one is nothing but the impedance. So for the resistive circuit, the impedance and resistance are the same. Am I clear now?
Yes, sir.
Thank you so much. So as I said, the next actually question, the current through a 0.1 Henry coil is provided by a current source like this. So if this one is the case, the circuit is like this. Somebody can actually draw the circuit, and if you can actually solve without actually drawing the circuit, I have no issue at all. So this is energized by a current source, unlike voltage source. So this is nothing but only the current source. If this one is the current source, find the voltage across the inductor. So my target is to find what is the voltage expression here, as well as actually we need to plot them. So there are two ways to solve. If you draw the circuit, the easiest thing means if you draw the circuit, then how do you solve? How do you solve? What is the voltage value? Like, what is the relation for voltage and current in inductor? We know V equal to L di by dt, right?
Yes,
so if
sir.
if you recall, closely, like when we calculate the voltage current relation in inductor, it was given the voltage expression. So we took integration and then calculate the current. But for this case, the current is given. All I have to do is to find the expression for voltage, and this is so easy. What is the L value? 0.1. I will just write down d by dt. What is the expression here? 7 sine 377 t minus 70 degree. So I will do apart from that differentiation, and I think it should be like this, if I'm not wrong. 263.9, then sine would be cosine, then 90 degree cos things. So 3 is 77 t minus 70 degree minus 90 degree, something like this. I'm not sure. You'll just do the calculation. Whatever you get, this would be the answer. Oh, that one would be plus 90 degree. So if you do that integration, then it would be done. This is one way to solve, and this value would be called the maximum voltage value. So this is one way to solve. But if you don't want to do the integration and multiplication all the time, then you need to find out what is the value of the reactance. Means I will consider everything as like impedance or the resistance like things. So what is the reactance for inductor? Omega times L, right? So I will find out omega times L. Omega is 377 times 0.1. So I will get 37.7 or something that we got here. So my target is to get what is the maximum voltage value. So we know the relation, the Vm by Im equal to XL or XC, whatever. So I can calculate Vm from here. So Vm equal to Im times actually Im time XC. So this is nothing but the XC. So Im time XC. So we can get the maximum voltage. Now, if you recall closely, I know the current in inductive circuit will lag the voltage by 90 degree. But right now I want to calculate what is the voltage expression. So for the voltage expression, if current lags actually voltage by 90 degree, then what will actually voltage do to current? Any idea? If you are leading
Question again,
someone,
please. Yes.
says India is leading by 100 runs. What does it mean? Like, let's say the game is actually playing between India and Australia. So what does it mean? Like Australia is lagging by 100 runs, right?
Yes, sir.
They're
Yes. So
yes,
if I
sir.
say the current will lag actually in inductive circuit if current lags actually voltage by 90 degree. That means the voltage leads current by 90 degree. Is it correct?
Yes, sir.
Yes,
Yes,
sir.
sir.
So much. If this is the case, I know the expression, the maximum value. This is Vm. I have written down what the expression is given here, like 377 t minus 70 degree. I have written down. Now, since it's a voltage, so in inductive circuit, current lags actually voltage by 90 degree. That means the voltage leads actually current by 90 degree. So leads means I will put a positive sign and write down 90 degree. Any confusion so far? And then I just did the calculation and plot it. I will not actually talk about plotting anymore. This is quite easy.
Yes, sir.
It should be quite straightforward. So,
Yes, sir.
all right.
Exactly. Exactly, sir.
Yeah. Now we'll be doing something not so simple, means not purely resistive or inductive or capacitive. Just think about another basic example. For this example, we have an series RLC circuit. So the current actually of the source is given in this equation, means this, and so this is omega t. So omega means 10 radian per second. So if this is the case, my target is to find what is the voltage across in a resistor, what is the voltage across inductor, what is the voltage across in the capacitor. So if this is the case, we all know in a series circuit, the current actually remains the same, right? Does current change, in a series
No, sir.
circuit?
No, sir. Current does not
No.
change.
Okay, thank you so much for your response. So in a parallel circuit, voltage doesn't change. We all know that. So if this is the case, just think about, that resistor. So the voltage across resistor means the current passing through resistor times, resistor. The voltage across, the inductor is nothing, since inductor and capacitor, we cannot say, there's a resistor, because we call it actually either impedance or reactance, and these have, the frequency dependent term. If you remember closely, we got, xl equal to omega l and xc equal to 1 upon omega c, if I'm not wrong. That was the expression, right? So in both cases, actually, there's a frequency dependent term. So if I want to calculate what is the voltage across, that inductor, we need to know what is the, just a second, give me a second. Okay, choose this. So what is the actually current passing through, in the inductor times what is the reactance of, the circuit? So reactance of, that component. So this is quite easy. So just think about resistor. Resistor is so easy. We know the formula. The maximum voltage divided by maximum current should be either resistance or inductance. Reactance. But since it's a resistor doesn't have any actually frequency dependent term, so it should be nothing but this value. So check, what is the maximum actually Im. Im is 10. I know the R value 2. So if I put, I can easily calculate, Vm. Now, once you are done, you have calculated only, the magnitude. But in AC circuit, you need to always consider, the phase too. Now, can you tell me, in a purely resistive circuit, just we have learned, does, current and voltage have any phase difference for a resistive term? No.
No, sir.
So there is no actually phase shifting or the phase, changing. So
So they
whatever
are
the
in the
phase,
same phase.
yes, thank you so much. So it means, whatever the phase we got for, current, we'll get the, same phase for actually the voltage. So only things, will be changing is the magnitude. Am I clear? Hello?
Please
Yes, sir.
Yes,
Thank you so
sir.
much. Now I will consider about, the inductor. So think about inductor here. So for inductor, I will calculate, XL. So my target is to calculate XL. We know the formula for XL equal to omega times L. Omega is given here 0.1 Henry, and sorry, L is given 0.1 Henry. Okay. The SI unit for, the inductor is Henry. So if it is given in microhenry or millihenry, we'll actually convert it to, the Henry. So if this one is the case, we can easily calculate actually reactance for actually the inductor, and that is simply, you will substitute, the value, and whatever you get, this is that value. If this one is the case, we can also calculate, what is the maximum actually value of, the voltage, right? Because we know Vm by Im equal to x. X always, I can write down xc or xl. For our case is L, so I would just, write down L. So from here, we can calculate actually Vm. So we know the maximum actually voltage value. Now I need to consider what is the phase difference. So can you tell me, if you recall what we have actually discussed earlier, so in an inductive circuit, how does actually current behaves? Means, does it lead or does it actually lag, the voltage source?
স্যার
So it's black.
ভিএল স্যার ভিএল তো 90 ডিগ্রি মানে লিড করতেছে।
Yes.
So it
VL, I said, how does actually current behave, because we took, the current as the answer or the reference thing. So we know the current will lag actually voltage by 90 degree, but my target is to find what is the voltage expression. That means voltage will lead actually current by 90 degree.
Current by 90 degree.
It's true, right? That I just gave an example. So if this is the case, I have written the expression like this: VL equal to VM sine whatever omega t we got, omega t is 10t. So I just write down 10t, and voltage will lead actually current by 90 degree, or I just remember one thing: current will lag actually voltage by 90 degree in the inductive circuit. So now I want to get the voltage expression. So I will just replace the terms. So I will say voltage will lead current by 90 degrees. So that's why I put a plus 90 degree. Any confusion? Or is getting like confusing?
No, no,
No,
sir.
sir.
Okay, thank you so much. And the second other things is like let's say we have a current source. This is the current source. We can calculate again in the similar fashion. We can get the xc value. So what is that xc value? Is nothing but 1 upon omega c. I just substitute all the value and we got that magnitude. So my target is to find again capital Vm. So capital Vm means current, maximum current times this. So I just replace this value and we will get the maximum actually voltage value. Now, if you remember closely, for a capacitive actually circuit, the current will actually lead voltage by 90 degree, right? So if this one is the case, I will just put a negative 90 degree. Any confusion so far?
স্যার যদি
No, sir.
ইম্পিডেন্সটা বের করতে চাই ওটা কিভাবে করবো? এটা তো স্যার একদম তিনটা মিলায় দিছে, লাইক রেজিস্ট্যান্স, ক্যাপাসিট্যান্স আর ইন্ডাক্টর তিনটা মিলায় দিছে।
Sorry,
Total
you.
total impedance, the
হ্যাঁ
whole impedance of the whole circuit. Sir,
হ্যাঁ
sir, in
total।
this case, sir, we have to think about the vector sum, right, sir?
Yes, perfectly. So, okay, it's a good question. Since we are not in rush, maybe I can actually teach you impedance. Are you actually doing an experiment on this? Like that's why. How do you know about impedance term? Because I have not actually used impedance
We
term
have
so far.
done.
So you
Sir,
have done it.
sir,
We have
laboratory
done
is
an
also
yes,
lab
sir.
is also required for
Okay, no
that.
problem. Yeah. Now
So
I will actually.
we needed to go through the theory.
Okay, I will actually clarify, the confusion between, the reactance as well as actually the impedance. Those are not, the messy terms. Just recall, let's say I have an inductor, I have an capacitor, and I have a resistor. So far we have learned what thing we can. Just a second. I think draw. There should be this. Give me a second. I don't know why doesn't it work. It has gone now. Oh, no. Just a second. Somehow it's not working. I don't know. Sometimes it works, sometimes it doesn't work. I'll reopen it. Give me 1 minute, please. I need to draw. One note. Right. Now it's okay. So we know this is the resistor, this is the inductor, and this is the capacitor. So we have learned so far. We cannot call it as reactance, but we know the formula for reactance here. Reactance is omega times L. The reactance for capacitor is 1 upon omega C. Now someone is saying, oh, they are a bit advanced. We want to know about impedance. Like, what is the difference between impedance and reactance? So I can teach you now. So remember, impedance is a complex number. Complex number. First, we'll talk about resistor. So for the resistor, we know the resistor is on here. So reactance is, although it is not called reactance because it doesn't have actually frequency dependent term, still R. What is impedance? This is also R, so it doesn't change. It's always what is it called, R or something like this. But for inductor value, this is called reactance, but what is the impedance for actually inductor value, you must to consider the phase. Now, can I write down like this? Voltage by current. You remember this formula? Although it's Vm by Im, but general formula of resistance or impedance. For impedance, the formula is okay. XL equal to Vm by Im. XC equal to also Vm by Im. But the impedance formula, let's say I consider ZL and impedance for this is ZC. This means not the maximum ratio, not the ratio between the maximum value, it is general expression V by I. This is the general expression V of t minus time dependent voltage, independent and time dependent current. Do you understand the difference? Then I will write down the next thing. So when I said reactance, this is the ratio between the maximum voltage and the maximum current for inductor as well as actually the capacitor. But when we actually refer the impedance, is just the ratio between the instantaneous value of voltage and instantaneous value of current. And for that case, how do you do that? This is very simple. This is nothing. X, whatever x we got, and then theta. Whatever x we got, and theta. So x is nothing but the reactance. So for this case, we'll just replace by XL and then XC. Now we need to calculate what is theta L and theta C. So can you recall what is the XL value for inductor? Omega times L, right? Hello?
Yes, sir.
Okay, what is the angle? Does current lead or lag in an inductive circuit?
Sir, it was lagging.
By 90 degree, right?
Yes, sir.
So this is the expression for impedance in inductive circuit. So similarly, this one is 1 upon omega c, and the angle is plus 90 degree. Okay. All right. Is it true?
True.
Okay. Thank you so much. Now, we can also express like phasor terms, means r comma theta in terms of a plus ib, right? Do you know that? Where r equal root over a square plus b square and theta equal to tan inverse b by a. Modulus and argument, right? Do you know this?
স্যার পোলার থেকে
Yes.
কার্টেসিয়ানে নেওয়া।
Yes, thank you so much. Is we are converting, from the polar actually like form to the Cartesian actually form. So if I actually replace this one into like convert it this one into actually Cartesian form, this one would be omega L times J. Generally we write I, but we in complex number we write down J. J is the imaginary term or imaginary number. J square means -1. Because I means current, right? So if I write down I omega L, then people will be like confused. Is this I is the imaginary number, or is this I the current passing through certain actually electrical components? So this one is the case, and for this case, since this is plus, so 1 upon or J omega C, or sometimes we write down J divided by omega C. So do you understand now the difference between reactance and impedance? So impedance itself, a complex number, means you need to consider the phase. These are for the pure inductive circuit and the pure capacitive circuit. But if the circuit is not pure, means it's a combination of inductor and capacitor, then the impedance formula will be changed. And we'll actually definitely calculate for the like hybrid system, means there will be some capacitor inductor or something. So this is the case. Now do you understand?
স্যার
Although it's
স্যার তাহলে ইন্ডাক্টরের ক্ষেত্রে যখন ভোল্টেজটা 90 ডিগ্রি লিড করে তখন কি সেক্ষেত্রে আমরা প্লাস 90 ধরে ফেজ অ্যাঙ্গেলটা মেনটেন করব?
Okay, you check this question. So when I have written this, so I have written the V ZL equal to V divided by I, right? I think I made a mistake. So this one would be plus 90 and this one would be minus 90. It's a mistake. So this one would be plus 90, this one would be minus 90. Why? Look, whatever the voltage value we got, what is the angle of voltage? 0, right? What is the current of inductor circuit? Negative 90 degrees. So if you have something like, let's say this is theta 1, this is theta 2, the argument says theta 1 minus theta 2, right? This is the relation for what is it called? The
leading
polar
or
form.
lagging.
Yes. So this one would be positive because the current will lag. So it would be, current angle would be minus 90 degrees. So if I actually take it on top, then it would be plus 90 degree, and you will get j omega L, and this is negative j omega C. How to go down? If we go down a bit, okay. Now, so simple now. If we know this thing, so let's say, although this is not a part of our like solution or the calculation for today. Right now we just solved a math. It was like 10 sine omega t. There was a resistance, there is an inductor, there is a capacitor. I don't know. Give a value, any value, 0.1 Henry, and I don't know, maybe, I don't know, let's say 10 microfarad or something like this. And omega value
কোশ্চেনটা ছিল 0.01 ফ্যারাডে
0.01
ফ্যারাড
Okay, we'll go for 0.01 actually farad, not microfarad. Okay, so if this one is the case, previously we asked you to calculate what is the voltage here, what is the voltage here, and what is the voltage here, and we solved in different way. Now whatever we have learned in actually DC circuit, we can also apply here, only the expression would be different. And how would we do so? So in order to do so, I will convert everything, means I will consider all elements as a like resistor like things. So in order to do so, I will change first the source into polar form. So whatever the maximum value, polar form should be Vm and angle theta m, angle of current. So here Vm value is 10, and what is the angle here? Is there anything with omega t? Nothing. So angle is 0. So I will convert it to 10, 0 degree. What is the impedance of resistor? Remember, let's say I consider this is ZR. I will consider as ZL. I will consider as ZC. So I convert everything into what is it called? Like impedance. Z means impedance. So what is ZR?
Sir,
ZR
it will
equal to
directly
R.
the resistor value, sir.
Yes, 2, right? So what
Yes,
is ZL? I just have seen.
Sir,
Like,
sir, it will be omega L then.
no, omega L is the reactance. If just right now we have discussed, the impedance should be J omega L. Okay, or omega L times an angle 90 degree plus 90 degree. So J omega L. So J omega value is 100 omega L. So J omega is 100 times L is 0.1 or something, and then ZC is nothing but, what is the value? 1 upon J omega C, or negative J omega C. Is it correct? Because we know J square equal to negative 1, right? So if you take that J on top, it would be negative J. Is it clear, or I need to explain this?
Sir, I have
No, sir,
understood
it's
it.
clear.
Okay, I think these are the very basic things. So you can calculate this one also, right? Negative J1 divided by omega value is 100 times the C. I don't know what is the value, 0.01 or something. So you know everything. Now, if somebody wants to calculate what is ZR, sorry, VR, VR is nothing. VR is nothing. You'll write down I, means this current, I times ZR. You remember the formula, voltage equal to current times the impedance. So you know the formula, voltage equal to current times actually resistor. But for the AC circuit or the generalized circuit, the formula is voltage across any element should be the current passing through that element times impedance of that element. So the voltage across actually resistor should be current times ZR. So you'll just replace the value. What is current value? 10. What is angle? 0 degree
0.
times R. R equal to 2, right? So 20, 0 degree. Now, what does 20 0 degree means? 20 0 degree means 20, then whatever the source, what was the source? Sine, right? So I'll write down sine, then I'll write down the omega t part, and this is called the phase difference. Phase difference is 0, so omega t plus 0. That means 20 sine omega t. Do you understand this part?
Yes, sir.
How to insert a new page here? I don't know. I don't know how to use that, but yeah, this we got something. Now tell me what would be the VL value? VL means what? The current times impedance across L, right?
Yes, sir.
So what is current? 10 angle 0 degree. What is Z? What is Z? 100 times 0.1 means 10, right? What is the L value?
Yes, sir.
If you have calculator, you can check. I may actually make mistake. I
না
don't
স্যার
have
এটা
calculator.
10ই হবে
10. What was that angle? If I have in the
0
Z,
ডিগ্রি
really?
না না স্যার 90
90 degree. So look, if I have two complex number, a theta 1, a1 theta 1, a2 theta 2, a2 theta 2, the whole thing should be a1 times a2, and the angle should be theta 1 plus theta 2. Similarly, if I have a1 negative theta 1, a2 theta 2, it means a1 times a2, angle should be negative theta 1 plus theta 2. We know this relation, right, from the complex number. So 10 times 10 means 100. This angle would be 0 plus 90 degrees. So whole angle would be 90 degrees. Similarly, if we want to calculate what is VC, the current times whatever the impedance across actually
স্যার
capacitor.
ওখানে যে 90 ডিগ্রি হলো ইজ ইট বিকজ দে দ্যাট মিন্স যে ওটা লিড করে 90 ডিগ্রি এই জন্য
Yes, yes. It means it has a sign of plus. So this voltage is leading the current by 90 degree. Okay.
as
So
we are considering the IL as the
yes,
reference point.
yes, yeah. So VC equal to I times ZC. So what is I? I is 10 angle 0 degree. What is ZC value? ZC means 1 upon 10 means 0.1. Angle is negative 90 degree. If you consider this one 0.1 negative 90 degree, because minus J means negative 90 degree, plus J means actually plus 90 degree. So in that case, 10 times 0.1 means 1, and angle is 0 minus 90 means minus 90 degree. That means this voltage is lagging actually current by 90 degree, negative 90 degree, and this voltage is leading by 90 degree, and this voltage are in phase. So if you solve in this way, you'll get the same answer. If you solve in the way I actually discussed earlier, we'll get the same answer. Am I
Sir,
clear now? Although this is not a part of your lesson today, but since you all
Yes,
are
sir, it is
interested,
clear,
I
sir.
just actually explain now. If you have done actually the experiment, so okay. One more thing actually I can actually teach.
Sir, in
Sir,
this
I
case,
have
sir,
a question actually.
Go ahead, please.
স্যার ভিএল আর ভিসি দুইটার ক্ষেত্রে কি আপনি রেফারেন্স পয়েন্টটা আইএল
Yes.
ধরে নিছিলেন? যদি
Yes.
আমরা ভিএল ধরে নিতাম তাহলে কি ভিএল যেটা ছিল ওইটা মেবি নেগেটিভ আসতো।
No problem. Still you can do, but the thing is, what is given here, the current source, right? So that's why I have
Okay.
considered current source as reference. If I convert like replace the voltage by current source by a voltage source, then we consider that voltage source as actually reference point. But the way of actually solving problem would be the same. Whatever we have learned in the DC circuit course or EE 101 actually course. So can you tell me now, these three actually like elements are in series, right? So what is the total impedance.
So this time it would be the vector sum.
Yes. So we know, from the resistance point of view, if this is a resistor, this is a resistor, this is a resistor, when they are in series, it would be simply the summation of all, right? So I'll just put the summation of all. Sorry, I'll put summation of all. This is plus. So I know the expression for ZR. I know the expression for ZL. I know the expression for ZC. I'll just replace. Go to the complex mode on your calculator and just calculate it, and you'll get the answer. Clear?
Yes, sir.
Any more question so far?
Sir, what if I don't want to keep those angles like in VR, VL?
Then it
So
will
that
not
can I?
work.
No. Can I use I RMS instead of I then?
So
Like,
say it again.
like sir, I suppose that I don't want to keep those angles like that. You have. Can you go a little bit down, sir?
Done.
A little bit
Sure.
down.
Mhm.
Yes, sir. Yes, sir. Here you have. Suppose if for VR, you have written that 20 sine omega omega plus something, right? So then, sir, in this case, I just don't want to like write that sine omega t this part. So then, sir, like I want to I want a numerical value, perfect numerical value. So then, in this case, can I, sir, use like instead of I, can I
You'll
use
just
I
put 10.
RMS? Yes, I RMS value. If I put the RMS value and then, sir, multiply it with ZR, can it can this be possible?
Yeah, I do understand your question, probably. So his question is like, what if we don't want to actually use that angle? So now it would be a bit problematic unless it's specified. So if you don't actually use the angle, then you cannot say, oh, this is leading or lagging. Yeah, you'll get the right answer for the maximum value. Means what is the maximum value for the current or the voltage on that actually particular circuit element. But AC circuit means it's a phasor thing, means you must to calculate the current with respect to the source. So this is the case. But if you don't want to write like this and somebody says, oh, I don't want to write like this, I want to write like this, have no problem. You'll get the same answer.
Yes, sir.
Yes. You do understand? So,
Yes,
but the like phasor form is the best, means the polar form is very easy to actually
the polar
calculate.
formation.
Yes.
Yes, sir.
So now I'm clear. So what I taught actually, you can get this results in the many ways, in like multiple ways. Do you understand?
Yes, sir.
Hello. Yeah. This is what I wanted to say. Now, so far we have learned, the time dependent actually behavior of capacitor or inductor or other the resistors. Now we want to learn something about the frequency response or frequency dependent term, because it's a AC circuit, we can tune the frequency. So if we want to actually tune the frequency, means if you are changing the frequency, how does actually the resistor change, or capacitor inductor changes. So we know the resistor is a property of DC circuit, means it doesn't change with respect to the frequency, that we have been talking a lot about it. So if I plot the graph against actually frequency, it doesn't change, it will be constant value. That's why this is called DC. So resistor doesn't like resistor is not affected by the frequency changes. How about inductor? For inductor, we know the reactance formula omega L. Omega means 2 pi FL. So what does it mean? XL is proportional to F. So if I increase the frequency, XL will actually increase too. So if I consider any term other than frequency as constant, let's say this is M. So we can write down XL equal to M times F. So this is an expression or something similar to Y equal to MX. Do you understand? So this is if this is the case, if I consider F equal to X and XL equal to Y, if I plot the graph, then what will I got? I will get a straight line relation.
Straight line from the center.
From the from the actually origin, right? So now this is the general symbol of actually inductor at low frequency, or the DC. Low frequency When frequency is 0 means it's perfectly DC. What does it mean? DC means frequency equal to 0. So if I actually put in a frequency equal to 0 here, means if I put in a frequency equal to 0 here, what is the value of XL? 0, right? Hello? Hello?
Sir, yes, sir.
Yeah, do you have a question?
No, sir.
Okay, thank you. So if frequency equal to 0, then XL value will be 0, means the reactance 0, means the impedance is 0. If impedance is 0, actually, then inductor will behave as a short circuit. So at DC, if you put in an inductor, let's say you are doing some experiment, instead of actually put a SSRs in your lab, probably from the November 6th, you will be going to lab, physical lab. So if you connect a DC source in the inductor, then it will behave as a short circuit. Means nothing is actually taken care of. So the second thing is, on the other hand, if I actually inject a very high frequency, if I put a very high frequency, then the XL value will be very high, means the impedance will be very high. If your impedance is very high, what does it mean? It's an open circuit, right? Do you know that from your EEE 101? Or I need to explain it again?
No, sir.
No? Thank you so much. Similarly, for the capacitor, we know the actually formula for reactance is Xc equal to 1 upon omega c. Similarly, if I actually replace omega with 2 pi f, we'll get something like this. So anything other than f will actually consider as a constant term. So if you check the relation between Xc and f, means the frequency dependent term, it's inversely proportional or the reciprocal. So if I increase frequency, then Xc value will decrease. What does it mean? At high frequency, the reactance of capacitor will decrease, means the capacitor cannot actually prevent much, but at low frequency the capacitor will be so strong, means the impedance of capacitor will be so strong, because we have the actually inversely proportional relation. So if I actually plot the relation with respect to frequency, we'll see at low frequency the reactance is very high, and then it will actually decay like this, because this is the graph of 1 upon x. So this is one of the case. Now if we check again, if I have a normal capacitor, it's like this. So tell me, at DC, how does it behave? It will be open circuit or short circuit capacitor? Will it behave as open circuit or short circuit? Any idea?
The capacitor, it will be open, right?
Just check, Xc equal to 1 upon, yes, you're right, Fc. So if I put F equal to 0, means very low frequency, means something close to 0. So if I put 0 here, 2 pi 0 times c, what is this value? Infinity, right? Plus minus, so forget about this.
Yes,
so if
sir.
it is infinity, what does it mean? If it is infinity, means a very high actually impedance, means it's an open circuit. So at DC capacitor behaves as actually open circuit, inductor behaves as short circuit. At very high frequency, if I put f equal to, let's say, 10 to the power 6, what does it mean? X equal to very small, right? You are dividing the whole thing by 10 to the power 6. So Xc would be almost 0, close to 0. So if I have this, then at high frequency, Xc will be behaving, or the capacitor will be behaving as a short circuit. Any problem so far?
No, sir.
No, sir? Okay, thank you so much. If not, I wanted to actually teach another things, but we don't have much time. So we'll actually skip that thing for the next class. Do you understand when I actually teach?
Yes, sir, I have understood.
Thank you. How about other students? Do they understand? Or they just join and sleep maybe, or they go for somewhere because I don't take attendance.
No,
Whatever,
sir.
Yes, I can
I'm attending class.
Okay, I have a practice problem for all of you. You can actually verify in 2 ways. Why? You'll have a very good actually idea or the basic of AC circuit, because if you don't understand actually the very basic of AC circuit, for the next modules, like for the next semesters, you'll be having some energy conversion classes and everything, which will be dealing with the AC circuit completely. Then you'll be really confused, like how did they get the leading, lagging, or the RMS values, or how to when to use actually reactance, when to use actually impedance and everything. So what I suggest, clear all of your actually basic things here, so you'll have a very good actually base for the next semester and everything. So what I wanted to do, like whatever you have done in the laboratory actually, PISPA simulation, you did something like this: resistance, let's say, then inductance, then capacitor. You had something like this, right, for the first experiment? Let's say this is 10 sine
Yes, sir.
377 t, but this is nothing but the 10-degree offset, okay? It's no longer 0. This is R equal to 10, L equal to, let's say, 0.5 Henry. These are not the realistic value, okay? So next class, don't say, oh sir, there is nothing called 0.5 Henry actually inductor. Why did you write this? There's a
No, sir.
just for example, huh? Okay, so let's say this is 0.02 farad. So your task is to find what is VR, what is VL. VL means the voltage across actually inductor. What is VC value? Similarly, what is IR, IL, IC? And show me also IR equal to IL equal to IC. When I say this value, all are actually vector. You can use any method, like the easiest one, if you go for the impedance formula, the only thing you check this one, the source was 10 sine omega t. So in the phasor form I have written is 10 angle 0 degree. But for this case, the phasor form should be 10 angle 10 degree, because this is 10. And then you will solve everything. This is the easiest thing to do. You can convert everything into impedance, you can get it. And there is another way of solving, like whatever we have done here, like the way I have solved here. So you can practice in both way, like and probably you will get the same results. Am I clear?
Yes, sir.
Thank you so much. This will be it for today. Do you have any more questions? We have only 13 students. Good. Out of 40 students, now 12. There's no problem. So do you have any more questions?
Sir,
Yeah,
this
sure.
is actually not for today. Today's class. In previous class, you have actually raised a question about that, sir, vector formation in our lab, sir. Did you remember?
I couldn't hear. Maybe I had internet issues.
Hello, sir. Can you hear me now?
Hello.
Hello, sir.
You.
Can you
Yeah.
hear me now, sir?
Now I can hear you. Please,
Okay,
actually,
sir.
can you repeat your questions?
Yes, sir. So then in the last class, you actually raised a question about that. It is not theory. It is not theory related question, sir. It is about that lab, sir.
No problem.
You have actually raised that question about that lab. That it will always be in the vector
Phasor.
sum,
Yes.
that phasor problem. Yes, sir. And I have
Maybe
actually done that math.
this Vs equal to this VR
Yes, sir.
vector plus VL plus
Yes,
VC.
sir.
And
Yes, sir.
this
Exactly.
Vs means this value, then magnitude. You'll get the same thing for this, same thing for this. Only this is called the KCL or KVL. This is KVL. You
KVL.
can actually
KVL.
apply the same thing for KCL. So actually the lab sheet was wrong. If I'm not wrong, since I have
Yes,
not
sir.
done the experiment, it should be wrong.
In that experiment, I have actually mathematically I have written the both of the answer, the sum that lab has asked me to do, and also the thing that you have asked me to do. And sir,
Which one is right?
Sir, after that, sir, yours one was the right one, sir. I think
It should be the
because
right one. Yeah, you
because
can talk.
I have used the direct formula that I have found from the internet, that root over the voltage
R1
of
square.
yes,
Everything
exactly.
is square plus everything is square plus everything is square. That is the total magnitude. Means, if I'm
Yes, sir.
not wrong,
Yes,
he
sir.
is trying to say
Yes, sir. Only in
VR
that time I
square,
have
then
found.
VL square plus VC square, and then angle should be whatever the angle of R plus L plus C. So this is also correct. So whatever you go for, that is correct, because this is the vector sum, right? So vector sum
Yes,
means
sir.
the total magnitude would be the magnitude of this square plus this square plus this square, and the angle would be the summation of everything. So yeah, whatever is correct, you can discuss with me if you have any more actual question. But the lab sheet is wrong if I'm not wrong. Since I'm not taking tomorrow's lab,
Yes, sir.
who's having lab tomorrow?
Sir.
Many of you are having circuit lab tomorrow, right?
Yes, sir.
So tomorrow's lab will
I
be
have.
taken by Saba madam.
I have.
From the next week, and onward, I will be taking the charge of the online actually lab courses, and she'll be conducting what is it called, like physical actually lab courses if university actually go offline next
Okay,
week.
sir. Okay,
Okay,
sir.
see you again. Thank you.
Thank you, sir.
Have a nice day.
Yes, sir.
Yeah.
Assalamu alaikum.
Assalamu alaikum, sir.
Walaikum assalam. Walaikum assalam. I will stop my sharing here.
Have a good day, sir.
Yeah, thank you so much.
Thank you, sir.
Thank you. Stop recording. Where is this stop recording?